Good morning, student. Today we will discuss EMF series and the use of EMF series. Lecture number 3, chapter number 3, Electrochemistry. In last lecture, we discussed how to measure the electrode potential with respect to standard hydrogen electrode. We also know the oxidation potential and reduction potential, definition of that. Also, we know the each electrode having oxidation potential and reduction potential. Both are having the same value, but the sign is different. Suppose oxidation potential is positive, then reduction potential is negative. So remember these points. Reduction potential equal to oxidation potential standard, both having the same value, but the sign is opposite. Now, what do you mean by EMF series? Once the standard electrode potential is measured with respect to standard hydrogen electrode and they are arranged in the decreasing order, then one series is obtained which is known as the electrochemical series. That means definition of electrochemical series is the standard electrode potential. Standard electrode potential, that means reduction potential. IUPAC suggests that consider as the reduction potential as standard potential. The reduction potential of various electrodes are arranged in a decreasing order. They are arranged in decreasing order. Then the series obtained is called electrochemical series or EMF series. Now this is the series preview of series is given. That means in a series, the top electrode having the highest reduction potential, then reduction potential decreases, then hydrogen electrode having zero potential, then it becomes negative, and finally it becomes most negative. That means that this is the series which is given in NCERT textbook. Now, based on series, we can get so many information. Before discussing that point, you have to remember this one most IMP points. Based on this, we can decide oxidizing agent and reducing agent. What is the definition of oxidizing agent and reducing agent? So remember from standard 11, oxidizing agent means the substance which is reduced act as an oxidizing agent. The substance which is reduced act as an oxidizing agent. The substance which is reduced, that means the reduction of substance take place. Reduction of substance take place, that means the reduction is easy. Reduction means based on reduction potential. That means the electrode which having higher the reduction potential. Higher the reduction potential, that means if the reduction becomes easy. Reduction becomes easy, that means it acts as the strongest oxidizing agent. Remember these points. Standard reduction potential higher the value of standard reduction potential, that means easy reduction, that means act as a strongest oxidizing agent. That means higher the reduction potential act as the strongest oxidizing agent. Now, strongest reducing agent. So obviously, the substance which is oxidized, substance which is oxidized act as a reducing agent. That means when substance will be easily oxidized, it having higher oxidation potential. That means oxidation potential is higher. Higher oxidation potential, that means we can say lower reaction potential. Oxidation potential higher than reaction potential will be lower. So higher oxidation potential, easy oxidation. Easy oxidation, that means it acts as a strongest reducing agent. Strongest reducing agent. Reverse is also true, that means oxidation potential higher, that means we can say reduction potential is lower. Here reduction potential is higher, so we can say also in terms of oxidation potential, the oxidation potential will be lower. Now here in EMF series we can say reduction potential is highest here, then decreasing, decreasing, decreasing. Reduction potential is highest. Reduction potential is higher, easy reduction, strongest oxidizing agent. So here fluorine F2 act as a strongest oxidizing agent. Now reduction potential decreases. That means we can say moving from bottom to top in an electrochemical series to act as a strongest oxidizing agent property increases. Strongest oxidizing agent increases. That means this F2 having a highest reaction potential. Highest reaction potential, that means in all half cell F2 act as a strongest oxidizing agent because it having highest reduction potential. That means moving from top to bottom to act as a strongest oxidizing agent increases. Now strongest reducing agent. Now reduction potential decreases, 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 and then finally at the bottom it will be lowest. That means reduction potential is lowest. Reduction potential is lowest, that means oxidation potential is highest. Bottom having highest oxidation potential. Highest oxidation potential, that means strongest reducing agent. Strongest reducing agent. So here lithium Li plus is converted to Li. That means this potential E0 Li plus 2 Li. That means minus 3.051. This is the reduction potential. That means oxidation potential. That means Li to Li plus equal to plus 0.351. That means oxidation potential is highest, positive. That means oxidation potential is highest. That means easy oxidation. That means it act as a strongest reducing agent. That means this is Li. Li act as a strongest reducing agent. This Li act as a strongest reducing agent. Now moving from top to bottom to act as a strongest reducing agent property decreases. Here strongest reducing agent, then weaker, so on. That means finally this F minus having most negative oxidation potential. F2 having reduction potential. So F minus having most negative standard oxidation potential. That means this F minus act as this is the strongest reducing agent. So this act as a weakest reducing agent. Weakest reducing agent. Now again here F2 is the strongest oxidizing agent. Strongest oxidizing agent. Now reduction potential decreases. So this Li plus having the lowest reduction potential. That means Li plus act as a weakest oxidizing agent. Finally, remember F2 is the strongest oxidizing agent. This F2 is the strongest oxidizing agent. Why? So it is having the highest reduction potential. Again, Li is strongest reducing agent. Strongest reducing agent. Why? So Li having lowest reduction potential, most negative. Lowest means positive becomes zero, finally negative, and most negative reduction potential. Otherwise, in terms of oxidation potential, it having the highest oxidation potential. Higher oxidation potential, easy oxidation, strongest reducing agent. That means Li is the strongest reducing agent. That means first application is we can decide the strongest oxidizing agent, the strongest reducing agent. Suppose potential are given, reduction potential are given, then arrange the increasing order of strongest oxidizing agent, increasing order of strongest reducing agent. So based on this, we can arrange. That means the first application is to decide strongest oxidizing agent, the strongest reducing agent, increasing order of oxidizing agent property, increasing order of reducing agent property. Suppose in exam question is like the arrange the following half shell, otherwise electron in their strongest oxidizing agent property. So remember, higher the reduction potential act as the strongest oxidizing agent. That means the electron which having highest reduction potential act as the strongest oxidizing agent. The electron which having lower oxidizing lower reduction potential is a slightly weak oxidizing agent, and so on. So in short, arrange based on standard reduction potential, otherwise decide based on standard reduction potential. Now, second point. Based on this series, we can decide which is the strongest reducing agent with respect to hydrogen, which is weakest reducing agent. The simple logic is there. Strongest reducing agent. Strongest reducing agent means easy oxidation, higher oxidation number. So these are all having the electrode having position below the hydrogen. Hydrogen having position here 0.01. So all below this having oxidation potential will be positive. Oxidation potential will be positive. That means it will easily undergo oxidation. That means act as the strongest reducing agent. That means reduction potential is negative. That means the electrode which having standard reduction potential, this standard reduction potential is negative. Hydrogen having 0. That means these are all act as a Stronger reducing agent than hydrogen. Stronger reducing agent than hydrogen. That means H plus 2 H2 couple. That means obviously the electron is having position above the hydrogen. That means having positive value. That means oxidation potential will be negative. That means it does not easily undergo oxidation. That means E reduction, counter reduction potential is positive. These are all weaker reducing agent. They are all weaker reducing agent. Then H plus H2 compared to hydrogen. So about the position in electrochemical series are weaker reducing agent than hydrogen, below position than stronger reducing agent. Our application is activity of metals. We can decide activity of metals. Activity of metal, that means we know metal having main characteristic to lose the electron. That means having more tendency to release the electron, otherwise loss of electron. That means the metal which can easily release electron, that means it can be easily oxidized. Oxidized, that means it having higher oxidation potential. Oxidation potential higher, easy oxidation. That means which metal having higher oxidation potential, so obviously in a bottom reduction potential is the most negative. That means oxidation potential is highest. That means the metal which is in bottom is the most active metal. That means in other way we can say moving from bottom to top, activity of metal decreases. That means in bottom having a most active metal. That means activity of metal means in electrochemical series, this series, moving from bottom to top, activity of metal decreases. Activity of metal decreases. That means in a bottom having a most active metal, in a bottom. So based on this we can say which is more active metal or which is not. Otherwise we can also arrange the metal in their increasing order of activity, and which is known as the activity series. Suppose in an exam potential are given, so obviously the metal is having higher oxidation potential. Otherwise we can say most negative reduction potential, that means standard potential, is the most active metal. Now fourth one is we can decide when cell is formed, then which half cell act as an anode, which half cell act as a cathode. That means to decide anode and cathode half cell. The simple higher the reduction potential act as a cathode. That means when we have taken two half cells from this series, that means higher reduction potential. Higher reduction potential, that means it having a higher position in a EMF series. That means electrochemical series. that means the half shell. That means suppose here half shell is here and one half shell is lower, then the position of half shell which is above is act as always a cathode because it having higher reduction potential. So that means reduction potential higher. That means when two half shell is taken, the half shell is having higher reduction potential. Higher reduction potential act as always a cathode, and another half shell act as an anode which having a lower reduction potential. Remember, this is the most important points from exam point of view. Higher the reduction potential, that electrode, otherwise that half shell act as a cathode. Another half shell automatically act as a anode. Now, based on this, we can calculate the standard cell potential. That means we can calculate standard cell potential. If we know the standard potential of two half cell from this electrochemical series, so we can decide this half shell act as a cathode, this half shell act as a anode. Then we can calculate the standard cell potential by using this formula: E reduction cathode minus E reduction anode. That means the standard reduction potential of cathode minus standard reduction potential of anode. Now point number 6. Based on this series, we can decide which metal when react with acid it will produce hydrogen gas. Which metal when react with acid and produce hydrogen gas. To produce the hydrogen gas, H plus is converted to H2. That means H plus plus electron is converted to 1 by 2 H2. That means in this situation, H plus is converted to H2. That means the standard hydrogen electron act as a cathode. Reduction reaction take place. That means H plus must be reduced to H2. H plus must be reduced to H2. That means cathode. Now metal act as an anode. Then metal will be oxidized and H plus will be reduced to H2, and from acid hydrogen gas will be given. That means based on this, the metal which is having position below the hydrogen, that means the negative reduction potential, oxidation potential will be high. So easily it undergo oxidation. That means oxidation of take place, hydrogen H plus is produced. That means the weak metal will release the H2 gas when react with acid. The metal having negative reduction potential is negative. Then it produce H2 gas with acid. That means all metal having position below the hydrogen. Now 7 point. When one redox reaction is given, then we can say whether the given redox reaction is spontaneous or non-spontaneous. Based on this, one redox reaction is given. That means from redox reaction we can decide which is anode, which is cathode. Oxidation reaction take place. That means that act as an anode. Reduction reaction take place. That means it act as a cathode. Now based on from electrochemical series, we can calculate the standard cell potential. standard cell potential once the calculate, then if the standard cell potential greater than 0, that means a positive, then a given reaction is spontaneous. Given reaction is spontaneous. That means calculate the standard cell potential, check whether it is positive or negative by using this formula. Then if positive, then given reaction is spontaneous, otherwise the given reaction is non-spontaneous. For that, the final conclusion is, remember this: E reduction higher, EG reduction strongest oxidizing agent, oxidation potential higher, EG oxidation strongest reducing agent. Based on this, we can solve any example. Remember, this is the most IMP topic for MCQ as well as solving examples.